Ma'am, you can start now.
Okay, thank you. Welcome back again. Very interesting. This will not take much of time, maybe 40-45 minutes. We can close it by 6:15. But why is this important again? It's a hype or it's the next computing revolution. So what do you think? I mean, if you ask yourself based on all the advancements, based on every country, there are top 10 countries who have actually invested, China being the top one. India stands at 7, China 14 billion, India at 0.7 billion, but still made some effort. So we are also in the race of quantum technology, pioneering, making technology as an asset, national asset. But is the convergence of quantum and AI too early? Is it a hype? Or can we actually see some kind of work or outcomes out of this? What are the future directions and challenges in bringing these two, I would still say, niche technologies? AI, even though the theory is there like quantum, but the computational power is evolving as in when we speak, right? Okay, to understand that, it is good to just feel that, okay, I know AI, now let me just integrate quantum and I'll do the same work in quantum and I'll provide some kind of an quantum advantage and quantum supremacy. Two very conveniently used words. If you see 5 years ago, Google said we have achieved Google quantum supremacy, and again it has taken back its paper. That's not the point actually what we're talking about. We don't want any supremacy. We don't want any advantages. What we want is a good merger, right? Good merger is finding that union. When we studied sets, right? Finding that union. Do we have a union? How do we know if we have a union? That is what we're going to talk about this in this session. So welcome back again to this session. Here we are exploring a fascinating intersection of two groundbreaking fields, you can say, which has changed the face of technology, software, how we are interacting, which is quantum technologies and artificial intelligence. Mind you, I'm not just saying quantum computing because I want to make it very clear in this session. I want to introduce to you the other verticals of quantum as well. Quantum technologies and artificial intelligence. Why do I want to introduce other verticals? Is because AI is omnipresent today. We are including AI everywhere. We are including AI everywhere. So when I say we are including AI everywhere, that means AI has no barrier. AI has no barrier. We are including AI in ECE, CSE. Just a second, I'm just getting a call. Okay, so all the departments we are integrating, all the fields we are integrating, all the bodies of enterprises we are integrating. Now you can ask, why can't we integrate AI with quantum? Very good. But do we understand the foundational pillars of both AI or quantum? Forget about AI because AI has come to application layer, which is again a good thing. I'm not saying it is a bad thing because once a technology or once a science turns into a technology and comes at an application layer, that means there is a mass revolution. That means it's like an entropy. A lot of people are using it. Like how AI today, low code, no code platforms, everybody is using AI. It's become something very user friendly. But fortunately or unfortunately, again, the other side of the coin is quantum did not become yet, which is why we have a chance, which is why India has a chance, which is why each and every one of us who want to make a career has a chance here in this. So before we dive in, let me set the stage. AI has already transformed industries. We all know that. Self-driving cars, say, virtual assistants, stuck agents. As we speak, my internet is listening to me and creating some kind of recommendations for me to become speaker in the next sessions. I don't know what it's doing. But the other hand, quantum tech is still in its early days, but the promise is big. The promise is huge, as we have seen in the previous session also, in the application of drug discovery in material sciences. Why again, I gave a thought about it. Why did ATAL choose drug discovery in material science and not financial optimization or security or communication? Then I thought, life is important, Baba. If I have to talk to you, I have to be alive. I don't, God forbid, if I got something, I have to go to a hospital and say, I have this. Do you have a cure for this? And the doctor should assure me, don't worry, Gopika, you will be cured. We have a so and so drug. But again, the fees are high. Again, I know that. But at least they should be able to identify what I have and provide a drug to me. So when we see a new science or technology comes, fundamentally we think about making life better, making life not luxurious, meeting the needs of humanity as a whole. We are very selfish there. We don't want to make rats' life better. We want to make humans' life better. Let it be, but at least luxury comes later. But AI today in a luxury stage. We want self-driving cars. We want virtual agents. We want this recommender engines. We want uh, things to be told to us what to do, what to frame, everything. So AI is in that luxury stage. But if we are using AI for the basic welfare, it is still good. The discovery is happening. But quantum here is still at that need stage. If I'm using quantum, I better make use of it for something that matters. That is why I think ATAL has chosen good choice again. Now, what makes this buzz of quantum AI so significant today is because of the basics of what quantum is offering, which is the principles, which is what quantum mechanics. I don't want to repeat to you what is the pillar of quantum superposition, entanglement, how you create two bodies, and once you open something, the other thing also fails or success. Everything you know, all you need to know is where to make use of it. That's all. The speed ups promise, again, it is a promise, not yet something that we can see tangibly. But can I exploit this promise in a good way? Is something lies the responsibility between you and me. Gates and algorithms have been designed. Growers in Indian scientist Shores is there. We are fearful about Shores. Growers, oracles, searching good. If you have a huge database, if you can search it in a given optimal time, good. If you cannot search it also, okay. But if Shor's algorithm is implemented in a quantum computer, that is where our communication systems will fail, because it is about factorization and finding the factors of a prime number, which is nothing but our strongest key is made up of. This is where AI also can come into picture for cybersecurity. Get our basics right is what I tell you. Tell myself also rhetorically, get the basics right. What is the current state and the potential? What can it do? It can do a lot of things. The promise is huge, as I told you. But where does it matter? It can do 2 plus 2 equal to 4. It can take 200 and 2000 different sets of molecules and find a good combination. It can take your traveling salesman to the right destination without repeating the route. It can actually schedule the ATC today, the aviation department. We have a lot of collisions, or maybe the lot of time delays. Collisions were once upon a time, not now, because they're indefinitely delaying the flights. The air traffic control, if you see, they want the scheduling to be very optimized, but they have no clue for airports, not like Vishakhapatnam, talking about airports like New York, somewhere where there's a lot of huge traffic, scheduling, logistics, financial modeling. Yes, all of us into stocks, marketing, in these huge markets. I want one day to just open my, I don't do stocks, but I'm just telling you, I just want to open my dashboard of Zerodha, Grow, or whatever it is, and then I want my algo trading to use quantum backend and say, today you choose these portfolios, you do this diversification, you will have this risk, you will have this maximum profit, and I just want to click enter. That's all. Go. I wish I could do that. Good. Financially, we will grow as the country, as individuals. So this is the promise, right? This is the promise. Algo trading is there. Where does quantum come into picture in portfolio optimization? Selection of stocks. Fortune 500 stocks, NYSE, BSE, whatever you take, I will take the every day morning. I'll take those stocks. I'll give it to a quantum processor. 20% of selection it will do. Rest 80% optimization. 80-20 principle. By square, you follow it when you are working with a hybrid quantum computation, classical quantum. 80-20 principle, portfolio optimization. Even if you see Accenture, even if you see Emphasis, even if you see D-Wave, whatever, any or gate based, they are doing 80-20 principle, which is working currently, the benchmark. Right? That is the potential. Logistics, Volkswagen, Benz, There are other companies which are actually working. DHL for scheduling couriers, they're actually working in it. Climate modeling, drug discovery. I told you climate modeling. There are UNESCO is actively working. Drug discovery. I told you personalized medicine and pharma companies are actually working. Remember, AI. All of the areas which currently I'm showing here, everybody are working with AI. Okay, AI is done. Quantum, more than 70% have no clue how to work, but they have access. Okay, quantum, they have access. That means they have data, they used AI, now they have a model, they have an access to quantum computer or a processor or a backend. I still want to call it as a backend. Okay, quantum QB. This model, how to run on a quantum backend, people are still struggling because of NISC again, right? Example in early use cases, these are there. I could go on and on talking about it. If there are people who are actually working in secure communication networking and all, people would definitely agree with me because we are also, as a company, we are working with secure communication quantum AI suits. I'll talk about it later, right? So current potential state is this: people have access. The big ones have access. Even you and me have access, right? Even I have an access to an IBM, Microsoft, Google, Xanadu, Penny INQ. I do have an access. AWS bracket, free tier credits. As an academia, you can apply, get the credits. AWS went one step ahead. AWS always does that. They have they have a collaboration with StrangeWorks. That means this is the abstraction layer. These are all the quantum backends. Quantum backends. These are quantum backends. This is AWS. Very bad at writing with pointer. AWS, and this is you and me who are trying to access. So AWS basically made an abstract layer. So I know Qiskit, I know Circ, I know any other thing, Python language, I know any other library. So AWS has collaborated with StrangeWorks. SW is a company which is like who developed this protocols, middle agentic orchestration in AI. How we do that? We bring multiple LLMs. We do this layer, abstract layer, and your agent works with multiple LLMs. Similarly, the StrangeWorks guys, what they did is they took multiple quantum backends and they have created an abstraction layer. And now you and me can just access and create benchmarks. I can run my algorithms in any kind of a domain, drug discovery, supply chain, climate science, secure communication, anything, and see how it is working. Okay. Plus, you always have AI tools in AWS. So now AWS has a set of library, quantum AI library. You can just go and explore which makes use of this principle, which not principle, functionality, right? This is the current state and potential. Future directions, I don't want to hype it up in future directions. Optimization, simulation, search and sampling. I would want to put it as optimization, simulation, search and sampling. What is optimization? Why do I want optimization in AI or in any way? In basic program also. I write a program as an SD software development engineer. I write a program for my company. My company comes and says, can you optimize it more? The client is asking for a more optimization. Optimization in terms of what? Again, it goes by the client terms. I want to optimize the speed. I want to optimize the scale. I want to optimize the time at which I can access it, downtime, whatever it is. So here, when we talk about optimization, I'm talking about choosing the best solution from many possibilities. Again, because the previous session we have the drug discovery example, 10 trillion molecules library, out of which 3 to 5,000 samples is the best possible solution a pharma company can have in its hands. Fortune 500 companies having their stocks put up on the market, stock market, NYSE, and me waking up in the morning when the stock market opens up and I get 10 best stocks to buy for that day, closed by 3 o'clock. And out of 10 best stocks, 5 will give me maximum returns, 2 may flop, 3 may be neutral. Still, my portfolio is diverse, right? So optimization is nothing but finding the best solution. Quantum does it 20% of my solution. 80%, I again rely on my AI optimization models. From routes to delivery schedules. Next, simulation. What is the simulation? I have an idea. I want to go to a funding person, a venture capitalist. I want to start up. So, so because I'm a startup person, I'm poor. I don't want, even though I am rich, I don't want to put my money. I want that venture capitalist money only. So what I tell him, I have an idea. Tell him or her, I have an idea, and immediately what the venture capitalist or angel investor asks, can you give me a prototype, an MVC, an MVP next, right? So what do I do? I will not go with the scaling part. I will not go with the user access part. I will not go with the testing part at huge. I will just simulate my idea into a proper working model, a basic model and give. So that's why I told you, even though you have an access to a quantum computer 8 qubit, always choose a quantum simulator for your idea so that you are not restricted in the circuit depth. You can build a good circuit, good enough circuit, run it on a quantum simulator, see if it is a good match for your problem, see how much you can optimize your classical part. And the quantum simulator is nothing but simulating those qubits on a classical backend. That's all. Powerful classical backend. That's all. And HPC, quantum HPC, that is what India is doing today, right? So are you good at simulation? If you are good at simulation, if it works, then optimize it to a quantum processor, because you will not have a luxury to use the same number of qubits. In simulator, I can use 150 qubits, but I don't have error corrected qubits in a processor, right? I should still stick to 8 to 20, whatever my limit is for my Q. So are you good with simulation? That is the future direction. Number one, optimization. Am I good with optimization? To be good with optimization, I need to know what are the best solutions for my possibilities. Correct? I need to have an idea. Next, simulation. Am I good with modeling the natural world? Richard Feynman said this. The nature is quantum. So if you need to model it, you need to have a quantum system, correct? Nature, he used word damn it, which I don't want to use. So when nature is like that, I need to involve modeling, which is quantum based. Do you think astrophysics is classical in nature? No, it is quantum in nature. Every space, every planet system, all the data that we are sending to satellite, receiving it is quantum in nature. Because we don't have such kind of a backends or processors, we are downgrading. We are the dimensional reduction is so huge that we are doing on these parameters that we can use classical modeling. If we can actually capture quantum, I go to a hospital, I sit in an MRI machine, right? What is the data that MRI machine is taking? It is a quantum kind of a data, but it is not going at that atomic level. But a lot of parameters can be modeled. That is why when you take a MRI or PET scan, still some things go unnoticed, which will change. I'm very sure when we are working as a company in quantum sensors, MRI combined, just imagine I sit in an MRI and the MRI can actually sense with precision, not just 10x compared to X-ray, but 100x compared to resolution at molecular level. It can actually give me which molecules can actually turn into cancer inhibitors. Okay, the biomarkers I can identify. Just imagine such kind of a quantum sensing, which is one of the vertical in quantum technologies, which can be combined with AI. So I'm talking about, but before going there, I need to actually know how to model an anatomy, how to model a human body, how to model this. That is all there. I'm not asking you and me to do the fundamental research. People have done it, made MRI machines, done all that. Now my responsibility is to understand the quantum physics part, quantum sensing part, quantum sensing plus AI part, and then go with quantum AI direction. So am I good with simulation? Example, predicting how a drug molecule will interact with a human body. Okay, classical computer approximately will do it, but quantum systems can potentially simulate it directly. Just imagine simulation. I would like to take an example of MBBS where skeleton used to come and sit on the, I'm not MBBS, but just saying, on a table, not sit, sleep on a table. And then people used to go around and then the faculty used to explain. Now what they're doing, they have actually 3D modeling, they have 4D modeling of how the human anatomy. People are actually taking, recently in Amravati, there was this VR summit which we went to. So they basically have a VR goggles they have put, they actually simulated the lab on which the rats are tested for drug discovery. So you take a rat, you inject it, you sit with that, you keep the molecule interaction, everything virtually it's been happening, right? And so the rats won't die. But that's not the point. The point is humans should not die for them. Exactly. So here, can I simulate with quantum? Yes, you can absolutely simulate with quantum because quantum system inherently are atomic level. So it's a good simulation. Lastly, search and sampling. Meaningful patterns, vast amounts of data. Can I get a right pattern? Quantum approaches can speed up this searches dramatically. AI can do design patterns, AI can give the patterns. But once the data is hugely being increased, then what happens? You actually require principles of superposition and entanglement to use the quantum physics in classical models, correct? This is where we are looking at. But what is stopping us? Error mitigation techniques still are evolving. Again, I wish I have paid more attention to my computer organization subject, CO subject, uh, where error correction mitigation techniques were being taught. But not that it is similar, but again, for a quantum processor, still error mitigation, error correction techniques are important. We are at that stage. Example is, just imagine today I give 2 plus 2, every time it is 4 in my classical systems. Just an example. But once I give it to a quantum, I need to take a measurement. I need to take a probability of how many times I'm giving shots, the epochs. And then the best will come. But just imagine I have an error corrected system. So at a one switch, I will actually get a answer. So now what is happening is we are doing zero noise extrapolation and variational error correction methods. That is why VQ is so important, variational quantum eigensolver. Different types of technology, qubit technologies are there. I would urge everybody to go and search for qubit technologies, different modalities. I'm sure people with multidisciplinary background with like physics, computers, electronics, computers, electrical computers, they would fall in love with qubit technologies because today we can be pioneers. Today, nobody said superconducting won the race. Nobody said IBM is the only modality. No, lot of modalities. We don't know which modality will win. But if you and me can come up with a different modality today, people are saying with NV center diamonds, they can do very good quantum sensing. Actually, through diamonds. We as a company are working with photonics, right? Light, using light as a platform to store data and to sense environment. Ultimately, the goal is the potential of future direction should be stable and scalable. Anything that you and me come up with, people don't care if it is great. People only ask, is it stable? That means, is your qubit coherent in nature? That means, how long can your qubit hold what you put into it? Or is it collapsing because of conditions, environmental condition? Today, we are saying it has to be at Kelvin space, cold temperatures. That is the temperature at the space you need to actually simulate in your laboratory, which IBM is doing, which QPI companies are doing. But is it stable? Is it feasible? No. I want tomorrow a quantum computer which I can work with in my room with my AC 25 degrees centigrade, room temperature. It should be stable. Only when it is stable, room temperature, I can work with it. I want it to be scalable. So today, scalability means, again, don't go to DBMS, all those things. But the scalability is if it can have an access to multiple users, if it can have access to multiple fields or domains, it's okay. If it is only initially, it can be targeted for specific domains. Why? Quantum computing today is very good with drug discovery, biology, chemistry, financial modeling, logistics. Why? Because they found an exact match. Tomorrow, you should need to see if your hardware is scalable for other fields also. Correct? Interdisciplinary collaborations are going on. Gone are the days wherein I have knowledge, I'll keep knowledge, I will win. No, you will fail. You and me will fail. If I as an industry think that I don't need academia, I can go ahead, I will fail. If collectively academia thinks that they are afraid of industries coming in for collaborations, they will fail. Industry and academia should work with each other because academia has huge knowledge resources. Academia has persistent patient capital, which is their brains. Industry can bring in money, industry can do technology transfer, industry can productize, right? So that is where research, productization, commercialization. As startups, we may not commercialize on a large scale. We need bigger companies, we need governments to come on board. But as academias, you cannot just stop with research. As a professor, you want your research to go to next stage. You want your research to see light. That is where you and academia and industry can come into picture. That is where actually quantum AI as a multidisciplinary field grows. So these kind of a fields, there's a lot of advances in terms of both algorithm and hardware design. Again, it is not just a hardware which is a challenge, it is both algorithm also. Today I have a great algorithm in AI, a model which is good with data sets, just with GPUs and AI based techniques. Can I actually encode that data using multiple encoding techniques into a quantum processor? Can I have a hardware which is designed to take this kind of a data and throw some result out of it? Correct. IIST and ISRO Space Tech, who offers PhDs and degrees, they're actually working on image processing, quantum image processing, QML. If you are interested, please explore that for a specific hardware design, different types of algorithm. We have image processing is a very old subject, correct? But new algorithms in quantum image processing, which for a specific hardware. Next, workforce and skill development. As future direction, as I told you, we require multidisciplinary workforce. If you have students, if you are a computer science department professor, I would urge you, please take students from sciences, from basic sciences, from electronics, from physics, from mathematics, from EC, EEE. Why? If you see our lab, we have a lab in Hyderabad. If you see in our lab, we have electrical, electronics, mechanical, optomechanical, physics, pure physics guys working with us. We have computer science guys coding with us and also in the lab. So why did we have to do this? Initially, we thought it's just physics. No, it's a combination of everybody. So that is where today physics people are actually being, I'm sorry to say, initially we thought physics was just a basic science, first year we can forget. We didn't respect physics so much. That is why we are in this stage. We didn't respect mathematics so much. That is why we are at this stage for AI. We need to respect physics and mathematics for what they offer. Doesn't mean I have to have a formal degree, but I have to include them in my research. I have to have an inclusivity. Inclusivity is not about gender. Inclusivity about the background that I have a knowledge in, right? So quantum mechanics is a combination of everything put into picture once you're trying to create a field, which is in AI and computer science and industries and academia. So they're very scarce. The talent is very scarce in nature, but we require specialized talent, right? Key challenges, as I already told you, these are the key challenges: qubit modality, algorithm bottlenecks, error rates. All these are key challenges, which even without you and me, also these challenges will be met. The only question is, will you and me contribute in this? As an industry, shall I do something about it? As an academia, are you willing to do something about it? Choose something and work diligently, not just research. Sorry, even we also, industry also should learn from academia. Academia also should learn from industry. Not just papers or not just ideas or money will take the technology together, technology forward, right? We're talking about two major big technologies like Bahubali, the climax, no? Two villains. Who is hero, who is villain, we didn't know because together they're fighting. It's like that. But here, both are winners. But to bring both of them together, we require multidisciplinary approach. If you're good with research as a professor, try to talk to industry people. How can I take this research forward? How can, because you have your own bottlenecks, no? You have very limited access to these technology vendors. What if your research actually is so good that these people don't have? How will I know that you're good with research? You need to talk to me. You need to talk to those people who are actually bringing them. What if I have a bottleneck? I'm not able to move forward with my experiment. And what if that research lies in your hands? I have to come to you and ask, knock your door. And this is where we need to open up, not just doors, but our minds. So everything will be overcome. The challenges if people from different backgrounds come together, different fields come together. I really love this paper. It's a recent paper. Whoever says quantum is 10, 15 years down the lane, they can keep waiting. They can miss the bus. I still remember 2014, 2015, I just started in academia. I worked for 3 years in academia. I was just working with data warehousing and DBMS, very new to it. Thanks to my professors who've taught me well. Just working with data pre-processing and knowledge discovery. KDD was a thing. AI was not a thing. Just new algorithms. AI was just hyping up. People are coming. MNIC data is being popular. I wish I could take note of it, but I did not. I was just focused on data mining and I left it. I didn't go to next phase. Later, I realized I wish I could have gone, because if you see the timelines, people have got into AI in 2015, 2016, 2017. OpenAI came in 2018, right? Before that, it was just in a stealth mode. So 3 to 5 years down the lane, we will have quantum advantage. That means today is a time we have to wake up. I have to understand the fundamentals, move on, translate my research, do something about it. There are very good practical timelines that IBM and Pascal have come forward and have given. Please read this. We maintain that credible evidence of advantage is likely to emerge In areas highlighted, the areas they highlighted is the areas that we spoke about. In the next 2 years, which is very short deadline, we don't want to miss the bus again. By sustained coordination between HPC, quantum, communities, and most likely the areas we have highlighted here, which is in the paper. I'll send this, right? That means quantum will work with HPCs, GPUs, AIs, whatever. Quantum will work with everything. That is when we'll have a quantum advantage. That is when we'll have a quantum advantage. Quantum supremacy is different, right? Quantum supremacy is something which classical cannot do it and quantum can do it. Long way, billions of light years, whatever Google supremacy promised, they have revoked it. Long way. But quantum advantage, yes, we can see today, which is a very good thing. Now, I will conclude in the next 15-20 minutes, but please pay attention. This will be very good for all of us if we try to do something. So as I told you, quantum is not just computing. It is quantum computing. I have changed the slide. Please observe. It is sensing. It is communication. And also materials and devices, which I did not put it here because we have covered it previously, material science, right? Materials and devices, nothing but silicon chips, vacuum tubes, whatever the transition is, classical computers. That means suit which material will suit to build a quantum device. Okay, that comes under materials, and what kind of devices will help in making this quantum processors or quantum devices in different modalities. Huge subject, but again, AI also can help it by pattern recognition and other material combinations. Number one, quantum computing plus AI. When you look at it, what do you see? All I see is fusion of AI with quantum technologies, with sensing and communication, synergy between quantum techs, faster computing. Everybody are so stuck with speed. Even me, I'm shameless, but I'll say this. 5 years ago, when I ventured in quantum, it all happened because my PhD guide told me, do something in QML, not just ML. I was working with computer vision in an industry. So I thought, acha, okay, then now I'll use a quantum backend for my same ML algorithm, computer vision algorithm. It will be the speed up. The speed up will suddenly exponentially, it will increase, and the results will be huge, and I don't have to optimize. First stress, the results will come. I thought of everything which I am supposed to do in AI, quantum computing will automatically do it for me, which I was wrong, right? Faster computing is not a mandate for all the applications. For example, material discovery is there. All I care about is give me a good combination of materials for my particular polymer or for my particular battery. I don't care about speed. You take your time, but give me a best combination, right? Drug discovery, I have time. I know there are different types of cancers. Nobody's asking me tomorrow to give me a solution for a cancer, but I have time. But I want the best possible chemotherapy for a suited precision cancer disease, right? Type. So it's not about faster computing always. It is about precision. That is where my sensing comes into picture. Quantum sensing comes into picture. It is about measurement. It is about security. It is about data interpretation. Measurement is when we say that what happens when you measure. Okay, always remember, nobody says that out of a quantum computer you get a quantum data. Today we're getting a classical data because when you measure, it collapses. Qubit collapses, right? And you take a probability of it, and then you take an output of it, inference. So are you able to measure it optimally? Are you able to cost optimize? As I told you, AI will actually help you in cost optimization for this measurement, and noise also in error mitigation techniques. AI is hugely helping in quantum error mitigation techniques. I would say there's a Singapore company, I could not recollect the name. They're working very good with quantum error mitigation techniques. So the two pillars is quantum computing accelerate or enhance AI algorithms. Example, you can take any neural networks, quantum enhanced. Okay, whenever I say quantum computing plus AI, again, it can be quantum inspired algorithms, quantum simulated algorithms, or quantum algorithms. Correct? Anything can come into picture. I can use annealers, which are not exactly quantum backends, but still annealers. I can use gate based. I can use multiple modalities. anything I can say, and still I can say I'm using quantum plus AI. It solves previously untraceable problems like this. That is this is a good research which is happening in quantum AI. This I love. This topic I love. Quantum sensing and AI, because we are currently working with Andhra Medtech Zone here with quantum sensors and MRIs. If you know, Visakhapatnam and Andhra Pradesh, Visakhapatnam, Andhra Pradesh Medtech Zone is there, AMTZ. It is one of the 3 companies in the world which actually manufactures MRI machines. We should be actually proud of it. So we have collaborated with them. We are in partners with them. We have quantum sensors, which are magnetometers in our laboratory, tabletop. We want to bring them here to these MRI machines. And there is an electric field, there's a magnetic field. We want to move the electric field and we want to take hold of magnetic field and go and see atomic level sensitivity for MRI machines, how it is possible for quantum sensors in combination with classical MRIs. Can we work it out? It's not hype anymore, because if India has a chance, India has a very good chance in quantum sensing, because we are very good service providers previously. We have very good ultra precise measurements in our country. So again, quantum sensing, MRI images is a very good example. Magnetometers, which go with this, gravimeters, gravitational forces. You're in a submarine, you're under, you want to actually measure the distance, which quantum sensors are very good with. AI powered quantum cameras for high resolution images. In biomedical also it is very good. Gravimeter, for example, you have what, this is a good example. When somebody is trying to dig a bore, build a building, to when constructing a building, we have so it's not superstition, it's a ritual. Take a coconut, a guy will come, and wherever the water is, the coconut will just turn, right? Now just imagine we have these quantum sensors. It will actually precisely tell you at what depth you'll get the water, which is currently being done in regions which are deficit with water scarcity. Good example, UAE. So noise reduction sensors, very good, not just in isolated labs. So our aim as Quantum AI Global Industry Partners is we don't want to isolate in labs. We want to take it to more settings in commercial. If you are in academia, if you are working, if you have basis in sensing capabilities, if you are good with magnetometers, classical, traditional magnetometers, gravimeters, you can always collaborate to have this real world outputs. Communication. There is something called as Y2K threat. I'll end it in the next 10 minutes, I promise. There is something called as Y2K threat, 99 to 2000 tak. People were so, they were nervous what would happen, but fortunately nothing happened. There was an easy transition. There is something called as Y2Q threat now, which is called as year 2 quantum threat. Now, what is this year 2 quantum threat? Once there is a powerful enough quantum computer, which is fault tolerant, noise mitigated, error corrected, it will break RSA 2048, which is a current encryption system. And what will happen once the current encryption system is broken? Basically, the countries will wipe out. The countries, our financials will come down. Our just stock market will wipe out. Our RBI thing will suddenly be zero. In movies, they'll show, no? Enter, suddenly the bank balance zero. So now, this quantum communication, what it does is, it has a power, something called as quantum key distribution. We have 2 phases of it, quantum safe security. We have post-quantum cryptography, which is currently securing our channels. But once a quantum computer comes, which is called as quantum key distribution, we need to use it all over the country, all over the channels, all over the applications, quantum applications. Here, AI can actually help you identify this and optimize the networks and routes. This is where AI can help you for your QKD channel distribution, quantum key distribution channel. I don't want to dig deep into it, but it is a very good area to work with. Entanglement and superposition, if you want to see real time, quantum communication is the field that you need to look at, because it matters a lot. If you send a key from Alice to Bob, how entanglement and superpositions are actually seen. Because I don't have physics background, I'm a computer science background. When I actually saw it in our laboratory 4 years ago, I was surprised. Things can actually happen. For secure data transfer, QKD, quantum key distribution, AI boosts in performance, AI built-in network management. These are some examples, and these are some potential areas. JP Morgan is currently working with this. Goldman Sachs is currently looking at quantum communication. HSBC is currently working with quantum communications with AI. These are the three major companies, right? Okay, there is a fourth vertical also, materials and devices, which I again told you, which we have dealt with, which is the basis. So silicon, who told silicon is a very good conductor? We can make a silicon chip and you can have those transistors. Who told us Moore's law sits well with the silicon chips? Who started with semiconductor industry? Who chosen these materials? Who chosen aluminum for most of our physical infrastructure for these laptops? So that is all discovery for quantum materials also, which is the fourth vertical. AI plays a major role because we have a huge data behind combinations. So as a summary, all I can tell you is quantum, AI, convergence, and future directions and challenges. Both are positive. Challenges are also positive. Advancements and importance is also there. Computing may AI adds speed, definitely discovery of new algorithms. These are the example applications, drug logistics and complex machine learning models. Sensing may, when I say complex machine learning, I'm not referring to the complexity involved in the backend. I am referring to you have a model. You have a model. Why algo trading did not see light so much? Because the data is so huge. Every time I take in one news, somebody says something, the stock goes down. And I cannot complain my model did not perform well because the data diversity is so much. So in order to take such kind of a sources into my portfolio management, my model is complex. My model has become complex. And I don't know how to build this pipeline to incorporate huge sources of data which are going into manipulating these stocks. You can take any example. This is what complex ML is there. And then optimization part. Data encoding part, optimization part. Two places we always have a problem, AI or quantum. Next, sensing. I'm not, problem in the sense it's not a weakness. It is a limitation as of now. We can go overcome it. Sensing may denoising. Denoising in the sense, classical MRI is there. X-ray, MRI differences. One is bone, the other one is goes at the muscle level also. And then once you say quantum sensor, it can go deep into atomic level, molecular level, and say which molecules are actually inhibitors, biomarkers, and everything. So the noise which you see in the classical sensors are removed. You can actually go straight away under earth where the water is. The lat and log is very clear. Pattern recognition and real-time action. Okay. Yes. So applications are medical imaging, navigation, and seismology. If you see seismic plates, where the seismic plates are more prone, I think Indonesia, Japan, everybody will be very happy if you have actually these gravimeters. So communication may network optimization and security threat reduction. What are those loopholes in security? Because today cybersecurity has become very vulnerable at the verge of AI that we don't know where the eavesdropper, where the hacker is coming, where is the loophole? Because most of it is an open source. People are no more using Java enterprise editions. People are using Python. People are building libraries. People are hosting it enterprise level. We don't know where the threat is coming in. We don't know where the SDK failed. We don't know where the pipeline, where the firewall has cheated us. So the only way is to increase AI's efficiency at the same time to have a quantum key distribution channels made. That is where secure communication and smart network routing comes into picture. These are some real world examples. I'm just exaggerating things. I'm just extrapolating things. Sorry, not exaggerating, extrapolating. These are the real world examples. People are actually working. And these are the link where you can see this. This is a description impact in quantum computing and AI. As I previously discussed this part. Sensing, people are also working quantum MRI. We are proud to say we are one of those people. Gravimeter, geophysics, earthquake alerts, navigation systems. Today we have our own navigation system, Navic, right, for India. Why? Why did we choose to do that? Because tomorrow, what if US denies the navigation? Tomorrow, China shuts off. What happens to our space programs? So we require something of our own. That is why we have our own atomic clocks built at NPL. That is why we have our own thing going. And AI always optimizes. When you say navigations, routes, simulations, anything, AI will optimize. These are the description impacts that is currently happening in this field in these examples, right? Next, finally, communications. We don't know what is happening in China for sure, but China is always in the top. Patents may, publication may, scientific discoveries may, industries may, startups may, venture capitalists, everything China is on top. We don't know what China is doing, but we'll not underestimate it. Right? It's like that sleeping lion. It will wake up, and when it wakes up, it will see India first. That is why geopolitically we need to be strong. China is number one in investment, 14 billion. We are at number 7.7, 6,000 crores national quantum mission is there. So, firstly, we have to secure our own country. Different people are doing satellite communication. China said it has one with Russia already made. We are still trying 100 kilometers thing. We'll go there, we'll get there, but we require again multidisciplinary people to come and work. This is the future. The future will be tomorrow. It's not just tomorrow. I'm sorry. It's not just tomorrow. Today, if you see, the wars are not fought with guns and missiles. It's completely technology-driven wars, right? When I say technology-driven war, Operation Sindoor, how did I get so much precision? Where is that hub? Pakistani hub is, where are the terrorists at? Because I have actually, the lat long is so precise, the algorithm is working so precise, the missile goes and hits there, correct? So tomorrow, once somebody has a quantum communication equipped, they will just break this channel where my missile is set. And the target simply will be again the source, which is a big threat to the origin country, correct? This is where communications between land or space is very important, enabled with AI. Again, as always say, lot of potential, especially in drug discovery, material science, and other fields of sensing communication. We have to be strong with our fundamentals. If you're working in computing, be strong with computing fundamental, and then go with AI convergence or integration. If you're working in sensing, be good with sensing fundamentals, and then AI communication fundamentals, network fundamentals, and then AI. Right? Once you are good with basics, immediately go and try to have some hands-on with these kind of frameworks. Quantum sensing and communication are capital intensive, but you have simulator tools. You can always use simulator tools. Get always practical experience. Dive deeper. Again, I want to connect back into materials and discovery. Back, if you choose this as an application, sit with an SME, sit with a pharma company. A small company is also fine. Sit with them. Take the data, sign an NDA. As an academic, sign an NDA. Take the data. Let your students under the supervision of faculty work on those small data set using the benchmarked algorithms like BQE, right? Start applying to the summer schools. These are some of the advanced topics, mastery, which is important to understand what is fault tolerance, what is fault tolerant computing, what are the bottlenecks, what is decoherence. See, today I trust 100 qubit quantum computer and I know nothing about decoherence. I make my model and application on that. And tomorrow I learned that the qubit is very high. I failed. It's like the phase 3 clinical trials failing. I have to understand what are the bottlenecks first. And I'm talking to professors here. I'm sorry if I have if I could not convey anything properly. You have all the research. You have all that treasure with you. Revise that treasure. Go back to fundamentals and start mapping where we can integrate AI and quantum. Here, I would say, as an academia, try to grow your network into industry. As an industry, we will try to grow our network into academia. It's very important to seek partnerships, mentorships, and collaborative teams, to attend workshops and webinars such as this. I congratulate ATAL and Murthy Garu and GVP also for taking this initiative at the right time. It's always, remember, moving forward, any technology that we work with is not neutral. It is not traditional. It is not standalone. It is combinatorial. It is interdisciplinary. It requires people from multiple backgrounds to come and collaborate. It is not time to compete. It is time to collaborate. Only then we can achieve a good direction in quantum AI. And only then we will have the strength to face the challenges. So these are few snippets from recent NVIDIA GTC Quantum Tech. Very good. Try to go through it. A lot of humor is there also. The road ahead is this. These are the three. If the takeaway, if you ask me from this session, I would say keep these best practices as necessary. When you say I want to achieve a credible quantum AI advantage, first define the standards and the existing benchmarks for the problems properly with relevance and fairness. Today, I can create a black box in AI and say that it is giving me 99% accuracy. That is what people are not believing. People are saying fairness, explainable AI, right? Have fairness to whatever extent. And that is where quantum comes into picture. Quantum actually can bring explainable AI a reality, make it explainable AI a reality. Next, publication of detailed methodologies and data sets, which research people who are into research are very good at. Once you do the literature survey, see what can enable reproducibility, what can be taken from the existing problems, and quantum AI can enhance it. And then maintain an open access and leaderboards to track evolving performance. Why do you think OpenAI has given free access? Why do you think OpenAI is coming to India? They don't love India because we as people have a lot to give to OpenAI in terms of our data, in terms of our demography, correct? Today I do some research, I can hide it in my pocket or in my closed journals or in my institutions only. But let's open source it. Let me put an archive. Let me just say this is what I have done. Is it good? I'll get a good feedback, right? Anyways, it's an archive. Anyways, I will have that first movers thing. And later, once I get the feedback, I will then try to evolve my performance. Any closed door discoveries will not see light. Any individual contributions will not scale. That is why Python has scaled, because it has become a community. That is why China is behind, because China is not into anybody's good looks because they have money. They're just doing it by themselves. But India, on the other hand, if we have something, if we have right people acting in the right time, we are not selfish. Whatever we have, we will give it. And while giving, our strength increases. So together, let's shape quantum AI convergence. I wish each one of us a very best in our future endeavors. Thank you so much for patiently bearing with me. Thank you. If you have any queries, I would try my best to answer. Thanks.
Thank you, ma'am. Thank you for your informative session. We enjoyed a lot, especially the stress you have given for the STEM subjects is really required. We are neglecting our physics, math subjects. Without them, we don't have our future. Now, session is open for any questions from the participant.
Good evening, ma'am. Thank you for your nice presentation, ma'am.
Thank you. Thank you. Thank you for
Ma'am,
listening.
I have one query related to sensing, quantum sensing and AI
Yes, yes.
for medical purposes.
Okay.
Ma'am, I am working a little bit working on signal identification from brain to spine.
Okay.
So, is there any possibility in quantum computing to communicate through brain to spine? If the some person is suffering from any damage in the back side of human body.
Got it. Dr. Ragini, right? Tiwari, Dr. Tiwari.
Yeah.
Dr. Tiwari, that's a good area to actually start with. If you can make a note, IIT Bombay, Dr. Kasturi. Yeah, IIT Bombay, they are the T hub for quantum sensing. Dr. Kasturi Saha is actually working with quantum caps, right? Which can put NV center diamond based, which can actually put, we know encephalography, EEG, right? So the pulses have been taken. The spine area of integration is not done by them. They're only working with the brain. If you want to collaborate with them, if you can bring something to the table, the call is still open for IIT Bombay Quantum Hub, Quantum Sensing Hub. They're actively looking for quantum sensing in medical devices, medtech, right?
Okay,
So
thank you so much, ma'am, for giving me this opportunity.
Kasturi Saha is very friendly. She's open. You can connect with her. Yeah.
Okay, ma'am. Thank you.
Any more questions? Any more questions?
Murthy sir, actually I want to know where we will get exam link.
Ma'am, let the session over. We can discuss. I already put in the group. Please, it is not the correct forum. Huh? Any more questions?
Yes, sir, you have discussed, but we don't know if we will continue to join the link or where we will get the.
Ma'am, give me 5 minutes. Let the speaker switch off. Please, ma'am.
Okay,
Give
sir.
me 5 minutes.
Okay, thank you.
Any more questions? So that I can call the session over? No more? Thank you, ma'am. Thank you for joining us and enlightening us on future of quantum computing and AI. Thank you, ma'am.
Thank you, Murthy garu. Thank you, everyone. I wish you all the best. Thank you. Take care. Bye.